Good morning, guys. Today we're going to be looking at what a function is. So this is something that you should have learned in 8th grade. However, since you guys skipped over 8th grade, we're going to learn it in algebra. So first thing, and there are going to be a lot of moments in this video where I tell you to pause to write things down. So this first one is the definitions. So we have two definitions. One, relation is a collection of ordered pairs containing one object from each set. And then a function is a special type of relation in which each input has a single output, which will make a whole lot more sense in a minute. So a set of ordered pairs are just points on a graph that were taken. Okay, so next we are going to look at an ordered pair. So we have 2, 4. So let's throw this on a graph. Right there, 2, 4, first quadrant. Okay, so what are we looking at? We're looking at an input. So our input is 2. Our inputs are our x values. And then we're looking at our output, which is 4. Our outputs are our y values. So in a function, the input cannot repeat. So what does that mean? That means that the x values cannot repeat. So anything on the x-axis cannot repeat. No repeating x's. Okay, so coordinate points, and there are 4 types of functions that you will see that we'll go through right now. So first one is coordinate points. So we have these 2 sets of coordinate points. So 2, 4, 3, 4, 5, 4, -2, 1, 7, 3, -2, 8. So both of these are relations because they are a set of coordinate points. However, only the top one is a function because it has no repeating x values, so no inputs. So if you look, we have 2, 3, 4, and those are all different x values. Next we have -2 and -2. So on that bottom one, you see how we have -2 and -2. So because we have 2 of the same x values, that's the difference. So on the first one, see how we have 2, 3, 5. We don't have any repeating x values, so that is a function. The second one, because we have -2 twice, that is not a function. So yes, function, no, not a function, okay? That's all you're looking at. Does the x repeat? So next, let's look at these 2 coordinate grids. So instead of looking at the actual ordered pairs, we're looking at them on a graph. So now these are discrete graphs. Discrete just means the points are not connected with a line. So we would not connect them. They're already disconnected for a reason. So first thing we need to do is called a vertical line test. So when we do our vertical line test, this is just vertical. We're just drawing a straight line up and down. So we're going to draw a vertical line through all the points. So notice on this one, each point touches a line once. On this one, though, you see how we only drew one line, but it already touched 2 points at the same time, so that cannot happen. So on this first one, each one only touched the line once. That's what we want. That tells us that it is a function. The second one, that line touched twice, so that's not a function. So yes, function, no, not a function. So again, now we have continuous graphs. So this is where the graph is now connected instead of just points on a line. So right here, we're going to do the vertical line test also. So if we look, so it doesn't matter where you put this vertical line. So you can move it anywhere. However, everywhere that I move it on that graph, it only touches once. But on this other graph, if I look, I drew a straight line up and down and it touched 1, 2, 3, 4 times. So that means that is not a function. So this pink one is a function. This burgundy-ish one is not a function. So no, not a function. Okay, next we're going to look at tables. So tables, again, just like ordered pairs. We're looking at the inputs, so the x values. So on this first table, we have a 1, 2, 3, 4, 5, and 6. Next, On this other table, we have 2, and if you look, it's 2 all the way down. So that tells us that this one is a function, and this one is not a function, okay? Next, we're gonna look at mappings. So with the mapping, this is completely new, and that's okay. You may wanna pause and just kind of process it for a moment, draw them out. That way you know what they look like. So we have 2 mappings. It's 2 ovals, and they are connected by lines. So this first side is the input side, the second side is the output side. 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 goes to 3, and 5 goes to 4. So notice that the arrows are going to each number. This is not something you would have to do. This is something that's going to be done for you. So you're just reading the data that's there, the input-output pairs. Okay, so once I have my input-output pairs, I would write the coordinates. So 1, 2, 2, 3, 3, 4, 4, 3, and 5, 4. So again, this is just like the first one when we had ordered pairs. We're looking at all the x values. So because there is no repeating x values, that tells us that it is a function. Let's look at this other side. We have input, output. The 4 is going to the 1, 5 is going to the 4, 6 is going to 2, 7 is going to 5, and 7 is also going to 6, okay? So we have 4, 1, 5, 4, 6, 2, 7, 5, 7, 6, and that is it. So if you look, the 7 repeats in the x values twice, so that means it's not a function. If you look though at the mappings, so on the first one, that pink mapping, notice that it's okay if 2 arrows go to a number, but like on this second one, if 2 arrows are going from a number, that's not okay. That's how you can tell with mappings. So yes, function, no, not a function. And that is it. Make sure you wrote down every single pair or every single type of function because you are going to be seeing them all week. Okay, bye guys.